Okay, today we're talking about solving multi-step inequalities. So the first thing we're going to talk about, I guess, is two-step inequalities. And you have done these before, so it shouldn't be anything totally new. And a two-step inequality might look like 10x plus 2,000 is greater than or equal to 4,000. Okay, keep in mind this has an x, this does not. So I can't combine like terms. This is where I go back to my PEMDAS and I kind of work backwards. So I subtract or add things on, then I would divide or multiply. And if there's exponents or parentheses, those kind of come last. So here I'm going to subtract off 2,000. These cancel. 4,000 minus 2,000 is 2,000. And I have 10x greater than 2,000. Now this looks like one of those one-step multiplication division equations or inequalities that I know how to solve. So I'm going to divide both sides by 10. These will cancel and I'll have x is greater than or equal to 200. Don't forget that we want this in set builder notation, and that is how I should write all my answer. That one was pretty easy, so now we're going to work through some that have a negative coefficient. You've seen this kind of stuff before, but we're going to review how to solve. So I might have something like negative 11x minus 13 is greater than 42. My first step should be to add that 13 to the other side. These cancel and I get negative 11x is greater than or equal to 55. Okay, then I need to divide both sides by negative 11. Now keep in mind, I am dividing by a negative. So what needs to happen with my sign? Good, I need to flip it. So I'll have x less than negative 5. And again, we write that in set builder notation. X such that x is less than negative 5. Try this next one on your own. We'll do 5 minus 10n greater than 45. Okay, so I should start by subtracting this 5 off both sides so that these cancel, and I'll have negative 10n is greater than 40. Then I need to divide both sides by negative 10. Because I'm dividing by a negative, the sign flips. And my answer is n, such that n is less than negative 4. The next thing we're going to talk about is using the distributive property. So let's start off with a good example. Let's say 4 times the quantity, 3t minus 5 plus 7 is greater than or equal to 8t plus 3. So I have variables on both sides, and I have to distribute. This is a lot, okay? So the first thing I need to do is obviously distribute. So I have 12t minus 20 plus 7 greater than or equal to 8t plus 3. If I can add these like terms together that I have, this minus 20 and the plus 7, that would be helpful. So I'll have 12t minus 13 greater than or equal to 8t plus 3. Remember, when I have variables on both sides, I want to move the variables to the left and my constants to the right. So to start doing that, I'm going to add 13 to both sides. These will cancel, and I'll have 12t is greater than or equal to 8t plus 16. Now I'm going to move my variable to the other side, so I'm going to subtract 8t off both sides. These will cancel. I'll get 4t is greater than or equal to 16. And lastly, I need to divide both sides by 4. So I get t is greater than or equal to 4. And of course, set builder notation on everything. Okay? Try this one on your own. Okay, I started by distributing, and then I subtracted my variables over to this side simply because I wanted to do 36 minus 30. Okay, because that gave me a positive 6. I do like the variables, and by I do, I mean math likes the variables on the left side of the inequality. So I went ahead and wrote it, instead of negative 18 is less than 6c, I said 6c is greater than negative 18. It reads the same way. It just means I flopped it all around. I divided both sides by 6. 6 is positive, so I don't have to worry about changing the sign, and I get z such that z is greater than or equal to negative 3. Okay, just a few more examples here. This one is going to be a little bit special, and let's see why. I have 9t minus 5 times the quantity t minus 5 less than or equal to 4 times the quantity t minus 3. So we see an awful lot of the distributive property. I take this, I distribute it here and here. I take this, I distribute it here and here. So I get 9t minus 5t plus 25 less than or equal to 4t, not 40, 4t minus 12. If I combine like terms, this will give me 4t plus 25 is less than or equal to 4t minus 12. Notice that we have 4t on both sides. So if I subtract 4t minus 4t, they cancel out, and I would be left with 25 is less than or equal to negative 12. That's just not true. And because 25 is not less than or equal to negative 12, the answer for this is the empty set, which is symbolized with a 0 with a line through it. Okay? So you don't just say it's false, I say it's the empty set. Okay? Remember, we want everything in set builder notation. This is the set builder notation. It is the empty set. There is no set of numbers. It's this 0 with the line through it. Okay? That's not the only kind of funky solution I can get, though. Let's look at this one. 3 times the quantity, 4m plus 6, is less than or equal to 42 plus 6 times the quantity, 2m minus 4. Again, I got a lot of distributing to do. Here I have 12m plus 18 is less than or equal to 42 plus 12m minus 24. If I combine like terms, 42 minus 24 would leave me with 12m plus 18. And over here I have 12m plus 18. they're the same on both sides? Well, it's not that one can be less than the other, because m is m by the reflexive property. But remember, this is a less than or equal to, and these two are obviously very equal to each other. When I have two things that are equal to each other, and I want to know what m is, I say that they are, or m has infinitely many solutions, or IMS. Again, we've talked about the empty set and infinitely many solutions when we talked about equations. We're just bringing it into inequality. So we're applying something we've already learned to something a little more difficult because we're not as used to seeing inequalities as we are to seeing equations. Okay? Thanks for watching.